Synthetic fibers. One of the primitive needs of man is clothing. Clothing was primarily done with natural fibers such as cotton, jute, silk and wool. Production of the natural fibers can be increased to certain limit, but that cannot fulfill the demands of the increasing population. Apart from their scarcity, natural fibers have certain limitations. These shortcomings and their need forced man to think for better artificial fibers. The first synthetic fiber was prepared by Carothers in 1935. Terylene is another artificial polymeric fiber extensively used for textile manufacture. These are superior because of durability, resistance to chemicals, no wrinkles, hence no ironing, less tendency to absorb water, dry quickly after washing, take up various colors and hence very attractive. However, these fibers are superior than natural fibers but accumulate static electricity. Fibers. The thin filaments of any material that can be spun into yarn and woven into fabric are called fiber. Examples are cotton, wool, silk, terylene, etc. Good fibers should have uniform length, less waviness and low mass per unit length. Classification of fibers. The fibers can be classified according to their source in nature as natural fibers, synthetic fibers, and semi-synthetic or regenerated fibers. Natural fibers. They are obtained from the natural sources. Natural fibers are further classified as vegetable fibers and animal fibers. Vegetable fibers. The fibers obtained from plants are called vegetable fibers. Examples are cotton, linen, jute, hemp, etc. These are cellulose fibers belonging to class of carbohydrates which are polymers of monosaccharides. Animal fibers. These are obtained from animals, hence called animal fibers. Examples are wool and silk. These are protein fibers. Protein of silk is known as fibrin and that of wool is known as keratin. Synthetic fibers. The fibers which are prepared in the laboratory, partially or completely, are synthetic fibers. Synthetic fibers are prepared by polymerization of simple chemical substances. Examples are nylon 6, nylon 66, terylene, etc. Semi-synthetic or regenerated fibers. Natural cellulose fibers are soaked in acetic anhydride, aqueous NaOH or CuSO4 solution and then treated with dilute H2SO4 so that their physical properties like luster, strength are modified, and such reproduced cellulose fibers are semi-synthetic or regenerated fibers. Examples are acetate rayon, viscose rayon, cupra ammonium silk, etc. These regenerated cellulose fibers are also called as rayons. All natural and artificial, that is synthetic fibers, are polymeric in nature. Polymer. A macromolecule formed by joining large number of repeating units is called a polymer. The repeating unit is known as a monomer. Preparation of fibers. Preparation of nylon 6,6. For preparation of this fiber, monomers used are adipic acid and hexamethylene diamine. When equimolecular aqueous solutions of monomers, hexamethylene diamine and adipic acid are mixed together, the COOH group of one monomer reacts with the amino group of another monomer to form nylon salt, that is, hexamethylene diammonium adipate. For preventing oxidation, sufficient amount of nylon salt is placed in a closed vessel containing nitrogen gas. When salt is heated up to 553 K, it polymerizes to nylon 6,6. Here, reaction of amino group takes place with the COOH group to form amide linkage by elimination of water. Thus, nylon 6,6 is a condensation polymer. Molten mass of nylon 6,6 is then placed in a spinneret and forced under pressure through fine pores into a closed chamber where hot air blow is passed. The solution, which is extruded, solidifies to give fine elements of nylon 6,6. Preparation of nylon 6, also known as Perlon L. For preparation of this polymer, sigma caprolactam is used as a monomer. When sufficient amount of sigma caprolactam is placed in a closed vessel filled with nitrogen gas to provide inert atmosphere, to prevent oxidation, and is heated up to 553 K, addition polymerization takes place to form nylon 6. Nylon 6 is a linear polyamide homopolymer, which is also called as polycaprolactam. Physical properties of nylon 6,6 and nylon 6. They have good tensile strength, good luster similar to silk, and they take up bright colors with wide range and are beautiful. Nylons are not affected by dilute acids and bases at room temperature. Concentrated acids like HNO3 attack all types of nylons. They are crystalline, polar molecules possessing sharp melting points. They are insoluble in hydrocarbon solvents and are soluble only in few solvents like formic acid, acetic acid, etc. Nylons are hygroscopic and oil resistant. Uses of nylon 6,6 and nylon 6. Extensively used as fibers in textile industries, shirting, saris, bed covers, etc. They are used in making brushes and scrubbers, toys, tubes, etc. They are used in making ropes and fishing nets. They are also used as reinforcement materials in plastic and rubbers, to make pipes, belts, tires, etc. Drawbacks of nylon fibers. With aging, the white-colored nylons turn yellowish and colored nylons fade out. They become brittle on long exposure to sunlight. Preparation of terylene, that is Dacron or polyester. Ethylene glycol and dimethyl terephthalate, that is DMT, are used as monomers for preparation of terylene. For manufacturing of terylene, dimethyl terephthalate and ethylene glycol are mixed together in a ratio 1:2. When the mixture is heated at 503 K in presence of catalyst zinc acetate and Sb2O3 in a closed vessel, trans-esterification takes place with formation of dihydroxy diethyl terephthalate and elimination of methanol. A terylene polymer is formed with partial elimination of ethylene glycol when a suitable amount of dihydroxy diethyl terephthalate is heated at 553 K in vacuum for 3 to 4 hours. Hence, terylene is condensation polymer and it is linear. Terylene contains many ester linkages, hence called polyester polymer. Terylene is melted and placed in a spinneret. It is then forced under pressure into a closed chamber in which hot air blow is passed. Thin filaments are obtained when extruded solution solidifies. If films are to be obtained, melt is cast on a rotating wheel. Physical properties of terylene. Terylene has high tensile strength. Terylene is insoluble in most of the organic and inorganic solvents. It absorbs less water, hence dries quickly. Its filaments are shining, have elasticity and are resistant to heat, chemicals, light, bacteria, etc. Uses of terylene. Terylene filaments are extensively used in textile manufacture as they dry quickly. Terylene is used in fishing nets, ropes, conveyor belts, parachute fabric and balloons. Terylene fibers are used as reinforcement material in tires and are also used in magnetic tape recorders. It is used to make filter cloth due to chemical inertness.